Welcome to this video on calorimetry. In this video we're going to solve some problems related to latent heat. So let's get started. So here's the first one. How much heat is required to melt 5 kg of ice? So always represent the given information in the form of a diagram. So 5 kg ice. I know this is too trivial, but too simple a problem, but still, as a habit, it's a good idea. So this is 0 degrees Celsius. You want to convert it into water of 5 kg water at 0 degrees Celsius. And we know that Q equal to M into L. Mass is, let's say, 5,000 grams. L is 80 calorie per gram. That'll be equal to 400 into 10 power 3 calorie. We need the answer in joules, so that'll be 400 into 10 power 3 into 4.2 joules. That's 1 calorie. That will amount to 1680 if you multiply this both into 10 power 3 joules, or 1680 kilojoules. So that was an easy one. Let's do the second one. How much ice is required to be added to 300 grams of water to cool it from 40 degrees Celsius to 0 degrees Celsius? So this is a typical calorimetry problem. So let us draw this problem. So here is ice. And plus 300 grams of water. And this is X gram, we don't know. Here T1 is 40 degrees Celsius, T2 is 0 degrees Celsius, and here T1 is ice. If it is not given, you can assume ice is at 0 degrees Celsius. You can say ice to water of T2 is also 0 degrees Celsius. Alright, so here the heat is gained by the ice, and heat is lost by the water. So here this is equal to. Now the heat gained is nothing but M into latent heat of fusion. That's equal to, here it is MC delta T for water. So let's substitute this. X into L for ice is 80 calorie per gram. So that's equal to 300 gram. It's always good to write units into 1 calorie per gram Kelvin. And here we know that delta T equal to 40 into 40. Or in other words, X would be 300 into 40 by 80 gram. That's 150 grams of ice. So it's very interesting that if you want to have a glass of cold water, you need approximately half a glass of ice if you want to make it 0 degrees, like in this case. Of course, the initial temperature matters. Alright, so let's do the third one. I urge you to pause the video and try to draw your representation. So here is a representation. Here is a heater. So the first step is to find how much heat is required to convert 1 kg ice to water. So delta Q is M into L, which is M is 1000 grams into L is 80 calorie per gram. If you want to convert this into joules into 4.2, so that will be 400 joules. This is joules per calorie. All right. Now this is the amount of energy required. Oh, sorry, I did a mistake here. This will not be this much. This will be equal to 4.42 into 8 to 336. 336 into 10 power 3 joules. But it's given that the heater has only an efficiency of 40%. So what this means is that energy of heater equal to 40% of power into time. So we don't know the power, but we know the time. We know that that needs to be happening in 30 seconds. So this is 40 by 100, which is 0.4 into power into time would be 30 seconds. Joules. So energy given by heater is this much, energy required by ice is this much. So we can now equate both of this. 336 into 10 power 3 equal to 0.4 into 30 into P, or in other words you will get P is 28 into 10 power 3 watts, that is 28 kilowatts. That's a lot of power. Let's go to the next problem. Here ice cube of 30 grams. Ice cube of 30 grams is added. So let this be the ice cube. This is 30 gram. Is added to 200 grams of water. At temperature equal to 30 degrees. This temperature would be equal to 0 degrees. So we need to find what will be the final temperature. So let the final temperature be T. If you look at the net heat gained by ice on this side, there are two components to this. One is the latent heat for it to convert to water, plus delta Q from 0 degrees to T degrees Celsius. So this would be the gain of the heat, and the loss would be on the other side delta Q from T1 equal to 30 degrees Celsius to T2 equal to T degrees Celsius. So this would be the delta Q loss. Heat is lost here. Alright, so let's equate the delta Q gain equal to delta Q loss, and delta Q gain is M into L plus MC delta T. Let's first label this. So this is A, this is B. So this is A, MC delta T for B. This is 30 gram into L is 80 calorie per gram plus 30 into 1 into delta T would be T degrees Celsius. That's equal to 200 into 1 into delta T would be 30 minus T here. So equating this, 2400 plus 30T equal to 6000 minus 200T, or in other words 230T would be 3600, or T would be 360 divided by 23, and that will be equal to approximately 15.65 degrees Celsius. So let's do some checkpoint questions for this video. I hope you'll have some fun doing these problems, these checkpoint questions. See you until the next one. Ciao.